If you like our video, click the subscribe button to subscribe to our channel and get easy access to new content. To see our full suite of ad-free video courses and training materials, visit us at teachucomp.com. Access is a relational database application. So what does the term relational mean and how is this important? The term relational describes the method used for storing data within the database tables. However, it may be easier to understand the relational model of data storage by contrasting it with another method of storage that you may be more familiar with. That method of storage is the flat file method. Information is frequently stored in large flat files. For example, assume you want to create a database file that stores your company's customer information. You would begin by listing the different attributes of the customer that you want to record. You may want to record customer information like the first name, the last name, the company name, and other relevant pieces of information. Perhaps you could create a table in an application like Microsoft Excel where you can create columns for each piece of information you wish to record. You can then list each customer's information in the rows underneath the columns, creating a basic table. Assume it looks like the example shown on screen. For many types of databases, the structure shown would work well. This is a flat file list or table. What you are doing when using this type of database is recording a single piece of information, like the first name, last name, or address, about a single entity, in this example, a customer. The reason this type of data structure works well in this example is because for each entity, meaning the customer, you are only recording information that has a one-to-one relationship to the entity. So what does this one-to-one relationship between the entity, meaning the customer, and the data that you are recording, meaning the first name, last name, etc., mean? What it means is that for each entity or subject, so once again in this case the customer, you are only recording information about the entity for which there is only one answer. For example, each customer has only one first name and one last name. They work for only one company. So the term one-to-one refers to the relationship between the subject of the table, in this case the customers, and the data collected about the subject in the table. Because for each one customer, there is only one possible piece of data to record in the column, the relationship between the data and the entity is one-to-one. If this is the type of database you are trying to create, simple Microsoft Excel tables work well. The problem occurs when you try to use a flat file approach to model a more complex entity or subject, like sales. For example, assume you wanted to expand the customer database from the last flat file database to also include sales data. Now, in addition to the information already collected, you also want to record each customer's sales. First, you would start by listing which data about each sale to record. Keeping the example simple, assume you decide to record the sale date, the items purchased, the quantity of items purchased, and the amount paid for each item. You may decide to then add columns for sale date, items, quantity, and amount to the flat file data structure. This may appear to work at first glance. However, you immediately begin to encounter problems when entering records into the file. To begin with, each time a customer makes a purchase, you must re-enter all the first name, last name, and other customer information again. This alone is irritating enough. However, you will also soon run into another problem. What do you do when a customer purchases multiple items in one order? One solution often proposed at this point is to enter another row with all the redundant information for each item purchased. However, doing this causes the table to grow quite quickly by adding all the additional rows, and each row will contain a lot of redundant customer data for each item purchased. This is not an elegant solution and will inevitably waste data storage space as well as the time and effort of the person who performs data entry. Another solution often proposed at this point is to create additional columns like item 1, item 2, item 3, quantity 1, quantity 2, quantity 3, and so forth, instead of creating additional rows of information. While this may seem like a good alternate solution, what will you do if someone purchases 100 items? Will you really create a set of 3 columns for item, quantity, and amount for each item purchased, producing a table over 300 columns across? Would you simply leave them blank if the person orders only 1 item, wasting valuable storage space? In this solution, you are simply substituting columnar growth or growth across for vertical growth or growth down. So this is not an elegant solution either. So why is there a problem now when there wasn't one earlier? The answer is now you are no longer trying to model a one-to-one data relationship in the table. Recording sales information is more complex than recording customer information. What you are trying to record now is referred to as a one-to-many relationship. Basically, for each entity, meaning each customer, you are now trying to record data in the columns which could occur more than once per customer, meaning the sales and the items ordered within a sale. You must allow for the fact that each customer may have many sales. You must also allow for the fact that within a single sale, each customer may order many items. The relationship between customers and or sales and items purchased is a one-to-many relationship. When trying to model a one-to-many relationship, you must then abandon the flat file method of data storage where you try to place all the information to record into a single table, and instead turn to the relational model of data storage for the best solution. Remember to click the subscribe button to see more of our videos. Get ad-free courses at teachucomp.com.